All right, greetings everyone. Welcome to the third part of the video for section 4.3. Continuing on with our study of properties of logarithms and how they help us solve equations, and we'll look at one additional application of logarithms as well. Okay, so let's continue on looking at some examples of solving exponential equations. And so we're going to work on the first one there. So the 6 times e to the 3x plus 1 equals 9. So rewrite that. And just like we saw on the previous problems, okay, the first thing we want to do in a problem like this is try to isolate the exponential term. So this e to the 3x plus 1. So we can do that by getting rid of the 6 there, and we can do that by dividing by 6 since the 6 is being multiplied by that. So divide by 6 on both sides. So that would give us e to the 3x plus 1 equals 9/6 can reduce to 3/2. And then we're going to take our log on both sides, but this time, since the base of our exponential is an e, we're actually going to use the version of log that deals with e's, so that would be the ln, the natural log. So we'll take the natural log in this case on both sides of the equation. On the left-hand side, that allows us to take the exponent, and notice it's the whole exponent, the whole 3x plus 1, and move it out to the front. So we'll have 3x plus 1 times ln of e equals ln of 3/2. And then this is the benefit of using ln when we have a base of e. Because think about what ln of e is. Remember, ln means kind of like log base e, and we're taking that of e. So basically what we're trying to say is, to what power do we have to raise e to give us e? And the answer there is just 1. So this expression right here, this 3x plus 1 times ln of e, really becomes 3x plus 1 times 1. But if you multiply anything by 1, you just get the same thing. So I'm going to have to move up, erase some stuff here. So what our equation is going to become then is 3x plus 1 equals ln of 3/2. We can finish there by then subtracting 1 from both sides and then dividing both sides of the equation by 3. So subtract 1 here, subtract 1 here. We'll have 3x equals, the 1's here cancel. ln of 3/2 minus 1, we're just going to leave those as 2 separate terms. And then we'll divide by 3 on both sides. And so we end up with x equals ln of 3/2 minus 1, all divided by 3, which we can plug in our calculator to get a decimal answer. Now be very careful when we plug in our calculator. We want to do the whole numerator divided by the denominator, so we're going to put parentheses around that. So do ln 3/2 minus 1, take that answer, divided by 3, and I end up with negative 0.198 as the answer there. Okay. So that's an example of solving exponential equations using or involving the number e as well as natural logs. Let's do the second one now. So for the second equation, and sorry, trying to erase everything here. Okay, so we have 2 times 1/2 to the tth power plus 6 equals 10. So we again want to start this like we've started all the other ones. Let's isolate the exponential term. So we'll subtract 6 from both sides. So then we have 2 times 1/2 to the t. 10 minus 6 gives us 4. We then have to isolate the exponential term by dividing by 2. And so that'll give us 1/2 to the t equals 2, because 4 divided by 2 is 2. Okay, so let me rewrite this now here at the top. So we have 1/2 to the t equals 2. We'll take the log or the ln on both sides. In this case, it doesn't matter since our base is not e, but we'll take the log on both sides. Remember that doing that allows us to take the exponent here and move it out to the front. So now we have t times log of 1/2 equals log of 2. Divide by log of 1/2 on both sides. And so what we end up with is t equals, and we have log of 2 divided by log of 1/2. So I'm not going to rewrite that right now just because of space. If we plug that into our calculator, we end up with t equals -1. So we get a nice solid number there. Okay. All right. I know I went through those kind of quickly, so if you want to go back in the video and rewatch how to do either of those, that could be recommended. All right, let's look at an application example. And here we're told that the cost of tuition for a full year, or 3/4, at Pierce is currently $4,531.50. And we want to know that if tuition has been rising by approximately 2.7% each year, when should students expect the cost to exceed $20,000? So now when we look at this, we see that we're given a percentage by which the cost of the tuition is going up each year. So that tells us we're dealing with exponentials. Also, because we have the percentage, that tells us we probably want to use that form of exponentials that are something like f of x, and actually, since this is an amount, I'm going to call it a of t equals lowercase a times 1 plus r to the tth power. And we're trying to figure out when. So it says, when should students expect the cost to exceed $20,000? This means we're looking for a value of t here. We're trying to figure out the amount of time it's going to take. So that means we should have the information for everything else. So let's go ahead and fill in what we know based on what's given in the equation, or in the problem, excuse me. So we're first told that the cost of tuition is currently $4,531.50. So that'd be like our starting value. So that'll go in for lowercase a. Tuition's rising by 2.7% each year. So that's a percent growth. Well, that'll go in for R. Remember, when we put that in for R, it needs to be converted to a decimal. So 2.7% is the same as 0.027. And then when students should expect the cost to exceed $20,000. We want to figure out how much time it takes to get to $20,000. So that will be our output. So this is our setup here. Is 20,000 equals 4,531.50 times 1 plus 0.027 to the tth power. And we need to solve for t. And at this point, this basically becomes one of the problems we were just working on, right? So we'll go ahead and isolate start by isolating our exponential term. So we'll divide both sides by 4531.50. Do that on the left-hand side as well. Okay, and then combining the 1 and the 0.027, we'll have 1.027 to the t equals whatever 20,000 divided by 4,531.5 is, which gives us about 4.414. And then because we're trying to solve for the value of the exponent here, that means we need to get that out of the exponent. So we'll take the log of both sides. So we'll log on the right, log on the left. That allows us to bring our exponent out front. So our equation then becomes log of 4.414 equals t times log of 1.027. We can divide by log of 1.027 on each side. Okay, so these will cancel. And so what we'll have is t equals whatever log of 4.14, 4.414, excuse me, divided by log of 1.027 is, and that we get 55.731, and our units there will be years, since this is a amount that the percentage we're given is the percent it raises each year. Okay. All right, we will leave it there for now. Thank you for watching.